Okay, so the next problem in the lead code we are solving is two sum. Okay, so basically what is being told here is we have got we got a list of numbers and a target, given target. Okay, so we need to identify if we take a sum of any two numbers, right? Are we going to get this target or not? Okay, so for example here the given target is 9. Okay, so what we could do is we know that if we take a sum of 2, right, 2 plus 7 here, we are going to get the target, right? So we can simply return the index of this and this one. Okay, so this is a way. So we have a multiple ways of doing it. Okay, so let's say that first foremost thing that what we need to understand here is, before solving this problem, so one basic thing. Okay, let's say that I am going to start, right? Basically we need to start from somewhere and we need to try out the combinations, correct? I will take a sum of these two and maybe take a sum of 11 plus 2, 11 plus 15, if it is constituting to 9 or not. Okay, I'm going to take a sum and identify it. Okay, that is one way of doing it, but that is like too much of time complexity, right? Like we needed to for loop to iterate through each of the elements and to find out a sum and comparing it with, right? Like it's like for loop to iterate through the numbers and then for loop to take a sum and compare it. Okay, it will increase the time complexity like of about O of n square. Okay, so to simplify this, what we could simply do is one simple math here. Okay, so let's say that I know I'm comparing with the 2, I'm starting with the 2. Okay, and I know I need to add it with some number, correct? I don't know what is it at, and to get the this one. Okay, I know what is the total sum that I am expecting. I have currently at the 2, I don't know what number to add to get this one, right? I don't know this, so I can simply keep it as x. Okay, so basically I can identify the x, right? This is a simple math in question. So I can say x is equal to 9 minus 2 and I get 7. So basically I'm looking for a number 7, right? I don't have to do all these things. Like I don't have to do each of the take this each of the sum and compare it with the target. That will be the too much, correct? So I don't have to really do this. Okay, so basically we can just say, mm, we can simply say come to this conclusion that x plus y is equal to z. To identify y, I can say that z minus x. Okay, so whatever the y value that I get, right, I can see whatever the element in the remaining list, I can see if it is found or not. Okay, I don't have to do anything extra there. Second, let me clear this. Okay, so now coming to this problem, right? So how are we going to solve this? So there are two ways. Okay, so one thing is you could say that you will find 2 and you will find a complement. You can look up for that number in the next coming list. Okay, and once you come to this point, you will again have to, let's say that if the list is big, right, you will have to do the same thing. Okay, you will pick this one, you will identify the complement and you will have to check for the here if it is exist or not. Maybe at some point in time you are here and again you will find a complement and you will have to check it here. Okay, this increases the time complexity, right? Again and again you are trying to find that element exist or that complement exist or not. Okay, to save the time complexity, what we are going to do here is we are going to store what is already visited. Okay, let's say that basically we are going to save a time complexity, so that's why we are going to take troublesome memory complexity here, right? We are going to store what is already visited and we are going to reuse that data. So okay, so basically let's see that how it is going to help. We are this will prevent us to go up to the O of n solution. Okay, we don't have to iterate again and again. Okay, so basically once I go to 2 and I will look for a complement 7, right? This is what I'm going to do. Instead of looking this data, what I'm going to do is I'm going to maintain my data structure. This is called visited. Okay, this is called visited. And do I see my complement there? Like, I mean, I will check if the 7 is there in the complement. Obviously it's a fresh one, right? I don't find it. Okay, so I will say that duplicate is not found and I will put this one current value to my data structure. And also we will also have to store the index because we need to index it. We'll see like how this index is helpful at that later. I will store this too. Okay, next thing is I will go to 7 and I will try to find the complement. What is the complement? 2, correct? 2. One thing is previously what we are doing is we could check it in the next iteration. Okay, or maybe we can check it from again, right? Simply instead of going there, I will go to my data structure which is already visited. I'm not going to look for this upcoming elements. I will simply check for the previous one. Okay. Mm, okay, 2 is found, so it means that complement is found, target is reached, so we can simply return the indexes of whatever that is stored and whatever the current index. Okay, so one thing that might be confusing here is like, why didn't we, like, I mean, how are we sure, right? Okay, we can rely on, like, I mean, we are pretty much sure, right? Like, let's say that let's say 2, right? When I'm solving for a 2, I couldn't find 7 there. I declare it as no, like I mean, no, it's not a part of the 2 sum, right? But ultimately, as we are storing it here, if it is not found with 2, ultimately it will find when we are calculating it for 7, correct? So when we are dealing with the 2, the empty, it was an empty dictionary, so we couldn't find anything. But when we are solving it for 7, its complement is 2, correct? However, that is already stored in that visitor list. We are going to anyway go there, right? That's why we are going to use this approach, and also this will save us the enough time. Okay, but like I mean, let's say that if you are using the other approach, right, like it will go to O of n square limit, but here we could solve it, we'll bring it to the O of n by using the already, like it's like caching the already visited numbers. Okay, so we are going to iterate through this. We are going to find a reminder or whatever the complement, I can say. If the complement is not there, is if it is there, it is like, okay, we found a target sum, so we can just simply return the indexes of it. If it is not found, we'll cache it. Okay, we'll cache it and later use it. Let's say that 2, when we are doing the calculation for 2, 7 was not found, but we'll still cache it. But when we are coming with a 7, right, when we are looking for a 2, 2 is there already visited. Okay, so let's say that let me take the another way. Okay, let's say that let's interchange it like this one. Okay, 11 2 comma 5. Okay, so in this case, what will happen, we will start with 7, but 7 is not found in there, so we'll store the 7 first, and also 11 will store. Okay, but when we come to 2, we need a 7, right? Like I mean, 2 plus, it will be like this, 2 plus this will be something is equal to 9. Okay, but we are looking for a 7. 7 is already present in the cache. We can say, okay, target is found, and we can simply return that. That's it. Yeah, let me clear this out. Yeah, thank you.